We've already seen how to do lighting, but I'm going to show you how to specify the way that an object is lit. So I'll just show you the program for this lesson. It's a spinning sphere, and as you can see, it's kind of shiny, which is new. We haven't seen shiny objects before. You can change some of the parameters of the material of this sphere, that is, the way it's lit, using the S, P, and E keys. So using the E key, I can toggle whether there's a little color emitted by the sphere, and so if it's turned on, if the emission is turned on, you can see that the sphere is a little lighter and a little more gray, because it's sort of an extra color added on to the sphere. Using the S key, I can toggle how concentrated the lighting is for the shininess. So toggle whether it's concentrated or whether it covers a large area. Using the P key, I can toggle how shiny the object is. So I can change it between being almost not shiny at all and being very shiny. Now let's take a look at some of the code to get all this to work. Up here we have three booleans: high shininess, low specularity, and emission. And these are the three booleans that are toggled using the S, P, and E keys. They're going to be used to set some of the parameters for the material of the sphere, as we'll see later. Then in init rendering, you'll notice that we're actually disabling GL color material rather than enabling it, because calls to GL material FV and GL material F that we'll see later require color materials to be disabled in order for them to work. Then we have over here where we set up the lighting, and we've seen all of this stuff before, except for this right here, calling GL light FV with GL specular. And that sets the specular, or shiny, intensity of the light. And we'll just set it to be the same as the diffuse intensity. And by the way, diffuse lighting is sort of the normal lighting that we've seen already. And if I run the program and hit P to almost turn off the shininess, you can see what the diffuse lighting is. It makes it so that the side of the sphere that's closer to the light is bright, and the side that's away from the light isn't lit. Now down here we have some variables that we're going to set based on the booleans, and those are going to be used in the material. And then we have some arrays indicating some information about the material of the sphere. First of all, we have the color of the sphere, which is this blue color. We have the specularity of the sphere, which is a color intensity, and this is the shininess of the sphere. You'll notice that it's this white intensity right here. We could actually change it to be red if we change the second and third elements to be 0, and let me just show you what that looks like. It'll make it so that the shiny portion of the sphere is red, like this. But we're just going to stay with this white color. And in order to determine the specular coloring, the shiny coloring for this sphere, what OpenGL will do is it'll take the product of this material, specularity, and the light specularity, this right here. So in this particular example, it'll take the product of 0.6, 0.6, 0.6, and specularity, specularity, specularity to give us the color 0.6 times specularity, 0.6 times specularity, 0.6 times specularity for the shininess of the sphere. Then we have the emissivity of the sphere, which is this right here. And if you turn on emissivity by pressing the E key, if you give it a little gray emissivity, then the sphere will emit sort of a gray color. It'll make it lighter and a little more gray. Now we're actually going to send all these arrays to OpenGL using calls to GL material FV. And you'll notice in all of these calls that the first parameter is GL front. And that indicates to OpenGL that we want this to be the lighting for faces that are facing towards the light. So in other words, the normal vectors of the faces are in the opposite direction of the light. You could set the lighting for the back faces using GL back or both of them at the same time using GL front and back. But we're just going to use the front faces. We don't want to set the back faces because we don't want them, for example, to be lit by diffuse lighting. So, first of all, we have a color to GL material FV with GL ambient and diffuse, and that's going to set the ambient and diffuse components of the lighting of the sphere. You could actually set the two components separately by calling GL material FV with GL ambient and then calling it with GL diffuse, but it's pretty common to set both of them at the same time, so OpenGL provides GL ambient and diffuse. And then we tell OpenGL the specular and emissive components that we want for the lighting. Or for the material, I should say. Then we have another parameter of the material, this GL shininess, which basically indicates how concentrated the shininess is. So if I just run the program, using the S key I can toggle whether the shininess covers a small area or a large area. So if we have a high shininess, a value of 25, then the shininess will be more concentrated on the sphere. It'll cover a smaller area. Whereas if the shininess is smaller, it'll cover a larger area. And this shininess has to range from 0 to 128. After that, we have a call to glut solid sphere. And for those of you who haven't seen it, it basically just draws a sphere. Draws a bunch of polygons that resemble a sphere. And the first parameter is the radius of the sphere. The next two indicate how many polygons you want to use to draw the sphere. And that's how we can use OpenGL to set the materials of objects, set how they're lit.